Hi everyone, welcome. Today we are going to show you a project called brain stroke detection using deep learning. So first we'll see how the final result will be. This is complete web application which is built with help of HTML, CSS, JavaScript and Flask. There are many more things here. So login is there, registry is there, admin login, patient login, and patient data will be updated with admin. Admin can enter only the patient ID to get all the informations, and the treatment recommendation and what are the causes. All the information things will be provided here. So this is a complete web application. Now I'll be showing you only the final result, how it actually gives. So when you upload, simply you will be going to get all these things. If it is a stroke condition, what are the causes and what are the possible treatments, can you see the and disease name, as well as this is the image highlighted. Even in our project we are trying to use explainable AI also. We'll be going to discuss everything, what we are doing, why we are doing, and we will be following, like we'll be first doing research on multiple IEEE papers existing, and we'll analyze what they are doing and what is the research gap, and then what is the existing system, what will be our proposed system, how our proposed system is better than the existing system, and then once we implement our proposed system, what accuracies and losses we are getting, whether our losses and accuracies are better than the existing system. Okay, so these things we'll discuss one by one, and finally we'll be looking at the complete demo of the project, how it actually works and what are the different part of the functions are there here, and what we are doing, how we are building the models, what models we are building. Everything will be discussed one by one. So initially we are referring 3 papers. So once you reach to us, we will be giving you synopsis as well as base papers. You can go through that. If you want complete project and implementation and execution in your system with explanation as well as with documentation support, we can be available for that. Okay, we will charge accordingly according to your requirement, and we will be helping you throughout the process. And if you have your own custom requirement also, we can able to help you, because if you come up with your own model or if you come up with your own data set, then also we can help you from selecting the topic to the final presentation. So these are the 3 IEEE papers which we are referring. You can see that 1, 2 and 3. So now first we try to understand what these papers are discussing about, what data set they are using and what models they are using, what accuracies they are getting, and what is the research gap they didn't mention. Okay, they didn't work on few technologies or few methodologies which are there, and how can we implement it to get a better result than the existing system. So we will discuss about these papers one by one. We already studied these papers and we made as a proper documentation. So I'll be showing you all the things here itself. You can see their accuracies they are mentioning 94, 97.28, 92.30, 91.61, different accuracies for the different models that this particular paper is discussing about. So what data set? Actually throughout the paper you need to concentrate mainly on its methodology. So methodology is the most important part. Here only they will try to present what they are doing. So when you check about the data set, mainly they are using data set which contains around 6000 CT images or DCOM images and PNG format images they are using. So we are using some other data set. We'll be discussing, okay, what remaining 2 papers are using, which data set they are using. So the same data set we are using. Actually these people are using some different data sets, and after using that data set they are cropping the image size 224 cross 224. Original dataset was 512 cross 512. Image size reduction they are doing, and in image augmentation they are doing so many process. What is augmentation and all those things I will discuss theoretically what is its importance and why we need to use it. And they are not concentrating much on the image pre-processing. Okay, so they are directly jumping from image augmentation to model buildings like EfficientNet model they are using, and they are going with the ResNet 50, that is ResNet model. They are going with VGG, that is Visual Geometry Group. It's one of the deep learning model, transfer learning model. Okay, MobileNet, again one of the transfer learning CNN model. GoogleNet. So they are using multiple CNN models on that particular dataset. And when you check the results, they already mentioned it at the abstract itself. These are the accuracies are there. Okay, final accuracy 97.93, 97.10, 94.90, 90.00, 92.40, and with them actually they are getting EfficientNet B0 as one of the best model with accuracy 97.93. So same thing you can see here. This is the first paper that we are checking. Okay, this is called Technofest to 2021. Okay, and AI medicine competition, one of the competition dataset they are using, and they are having around 6,000 brain CT scan images at DCOM format, and used for study are actually 2,500 images. Total 6,000, but 2,500 images they are using, and it contains around 7 different classes, we say. And then what preprocessing they are using? Under preprocessing, that particular paper whatever we saw, they are using only resizing. Okay, and in image augmentation, they are doing rotation, zoom, shift, brightness variation, all those things. Okay, so why they are doing it is to overcome the overfit or underfit issue. Okay, so what is this overfit, what is this underfit, why we need to use augmentation, I will discuss when I will propose my methodology. You just remember that these people are doing that thing, they are not skipping it. So why they are doing and why we also should do this, and we should append our own new technology or methodology. So then comes deep learning models used. EfficientNet B0 is being used, which is 19, ResNet 101, MobileNet V2, and GoogleNet. So these are 5 different CNN transfer learning models are being used in this particular paper. And what model we are using, I will tell you. And for training, the hyperparameters, they are training for 70 epochs. We are training for 100 epochs. Our dataset is actually different than this paper dataset. Remaining 2 papers, actually they are using exactly what dataset we are using. So when we do proper comparison with those 2 papers will be meaningful. So this paper are using some other data available. As I told you already, they are getting accuracy 97.93 with a classification report parameters like precision 97.96, recall 97.93, as well as F1 score 97.93. These are the different accuracies are being bought for this particular model with their code. And finally, the conclusion is very simple: EfficientNet B0 is overtaking all other models. Now comes this second one. So this is second paper, so which is 2023 paper, IEEE paper. So brain stroke detection using CNN algorithms. So in this, what models are being used, what methodologies are being used, what accuracy they are getting, we'll see one by one. If you check methodology here, you will get you will understand these things in the methodology. What dataset they are using? They are using dataset which contains 255 CT images, 950 healthy images. So the same dataset we are also using, exactly same dataset we are also using, same number of images. So when we compare with this paper, the comparison will be meaningful. And when we check into their proposed methodology, they're directly trying to jump to the model. They're not trying to define what pre-processing they are using. They're not much clear here in model building stuff. They are trying to mention their CNN models. Okay, they are getting around accuracy of 95.72 or like that, but final results how they look like. Okay, 95, or no, not AUC, this is AUC. You no need, you no need to check AUC. First search only for accuracy. Accuracy is only that much here. You can see here epoch wise they are training for 50 epoch, it is going just above 85%. It is not actually 90. 95 is AUC curve value. Accuracy is not 95. Okay, so you will be seeing that here. We already studied that and we made it as a note. You can see here CT scan images 250, or sorry, 2551 images are there, and 950 will go for stroke, and non-stroke 1551. Same, exactly same dataset we are using. Okay, they are using custom CNN models for stroke versus no stroke. And then under pre-processing techniques, actually they are trying to mention this. Okay, Grayscale, researching, and CLAHE. And then deep learning models, they built is the custom CNN models with their own layers. Actually custom CNN first of all is primitive when you compare it with the transfer learning models. Transfer learning models will always perform lot better than the custom CNN model. You should remember that. So they are splitting a dataset 60 and 40. This paper's drawback is that they are not handling the imbalancing, they are not applying augmentation, they are not doing proper pre-processing. They are touching some technique, but it is not in that way, it is not in the proper way. So if they do in proper way, then only we can able to get the better result. So that leads to the low accuracy of their result, around 95.5, 95.2 they say. But model accuracy, training accuracy are like that, they are getting around 90%. Okay, AUC is around 95.2 as I mentioned. So this, if you can see the graph, you will understand so what I am trying to tell you. In that graph it is very clear, it is nearly 90%. And then comes the third paper. This is the third paper. So in this, what approaches are being done and what accuracies they are getting, and when you see their proposed method, so they are using even the same dataset that we are using, exactly it is same. So they are using their own custom CNN model, and then they are taking few more models like ResNet 50, which is 16, and MobileNet. So their accuracies, training accuracies, remember training and validation accuracies should be near to each other. But this completely overfit model. You see here, MobileNet is 98.96. This is actually 87.90. Okay, so this is completely okay. There is a high gap between accuracies. Okay, so we call this as an overfit or underfit issues. So they are giving a graph and they are giving some results, but this paper is not at all giving good result, and it is completely overfit. They are not concentrating much on pre-processing, they are not concentrating much on balancing the dataset, they are not speaking anything, they are just going to those three models and they are implementing it. So now you see, it is not so important only to concentrate on models. You should concentrate on pre-processing, you should concentrate on balancing, you should concentrate on highlighting, you should concentrate on so many other parameters of analysis for analysis. So then if you build the model, you will be getting better results. So that's what we did, that's what we are getting better results. If I show you, so what pre-processing things we done, why we done, other things I will explain you. Theoretically I will explain you. If you want the complete working code and implementation, you can always contact us to the given number, you can WhatsApp us, you can directly call us, so we'll reach back to you. Okay, you see how we done pre-processing, and then we balance them equally, and then we have built the models. So when you see the models, it is 99.78, but more than 90. Actually this is fluctuating, actually we are getting 95.50, validation accuracy, and when you see testing accuracy, it is crossing 97.25, which is far better than those two papers which we referred. One was getting around 89 to 90%, and another one was getting validation accuracy was 87, like that. So validation accuracy and training accuracy were much different. Test accuracy is much different, but in our case, training is 99.75, testing is 97.25. You can see even classification reports, how our classification report is coming: 97.25, 97.41, 97.07. So which is far better than those two papers which we referred. What making this? And one more thing positive in our work is we are implementing explainable AI, far better than the existing papers, far better than any existing paper on this data set, whatever we studied. So our model, our methodology overtakes their accuracies and their results, as well as we are making sure we are using the best technology for analysis of the results, like explainable AI. So we are doing all those things and we are getting the better result. So what model we are using, why we are getting all this, we'll discuss one by one. So before moving further, first of all, we'll understand the theory behind this. What is that brain stroke, and how it can be detected, what is happening there. So we'll try to discuss about that disease little bit. So brain stroke nothing but because of some not proper supply of oxygen to the particular part of the brain makes that brain inactive. Okay, so that we call it as a brain stroke. Okay, that particular part of the brain will be like dead, it won't work. Okay, brain cell, because the brain cell will die without any oxygen or like that. So this is what we call as a brain stroke. Okay, so it happens because of the proper blood flow will not be available properly in that area. So this condition will happen. So how does stroke happens? So this stroke happens in multiple ways, and we have a name for that. So blocked artery, okay, we call that as ischemic stroke. Okay, this happens, this type of thing happens because of the blood clot. Okay, and caused by what, in which situations? Fatty deposits in arteries or clot routes to the brain. So like these things, these two situations will cause that particular. And second type is that burst blood vessel. So in this case, actually weakens the blood vessels, ruptures and bleeds into the brain. So the bleeding in the brain will cause this issue. And then what are its causes? High blood pressure, okay, aneurysm and head injury. So like these problems will cause that issue. And type of strokes, what are the different type of strokes what we studied above? They are there. Okay, ischemic stroke is there, hemorrhagic stroke is there, transient ischemic attack is there, cryptogenic stroke. So what are they, what causes them? Okay, caused by the blood clot blocking artery, caused by bleeding in the brain, and mini stroke. Okay, temporary blockage of that results in minutes of 2 hours. Okay, stroke with no known cause. Okay, cryptogenic stroke. So four different strokes are there. And the last one is brain stem stroke. Okay, effects of brain stem may impact both sides of the body. Treatment of this, so how it can be treated? The first one is ischemic stroke treatment. There are three different type of treatments are available. Why we are discussing all these things is that when we build some project, we need to know the purpose why we are building. Okay, so before, if you want to know the purpose, you need to know about the disease first. So then where we need to integrate our technology to solve the present existing system, we should understand all this, then only the work will be meaningful. So it is not like you are blindly coding some xyz. Okay, why we are coding? So if you study about this information, you'll understand where our technology actually fit, where it will come and solve the issue in our existing problem. The first technique is tissue plasminogen activator. Okay, so here what will happen is clot busting drug are effective if given 4 to 5 hours of stroke. Okay, so they will give a drug that will burst the clot, so it will make sure it will clean the brain. Okay, surgical removal of the clot using the catheter. And the third one is antiplatelet drugs. Okay, so those to prevent the further clot. So if some clot is happened, we will prevent the further clot. Hemorrhagic stroke treatment. So this kind of brain stroke, how it can be treated? Emergency surgery can be done, okay, to stop the next bleeding, because it happens due to bleeding in the brain. Okay, aneurysm clipping or coiling prevent further bleeding from the aneurysm. And blood pressure management, rebleeding, it will stop, they will stop to stop the rebleeding, so that no further destruction will happen in the brain. Post stroke rehabilitations are there. Physical therapy is there, occupation therapy is there, speech language therapy is there, psychological supports. So these things are needed after that, because after that the person will become very weak. So to make sure he comes back, he fit into the society, some things need to be done with communication with the patients, and make sure they will feel happy. And when we discuss about the statistic of this worldwide, around 15 million people suffer from this annually. 5 million deaths will happen, and 5 million people are actually disabled completely. So stroke is the second leading cause of a death and third leading cause of a disability worldwide. Remember this. In India, what are these values? What is these statistics in India? 1.8 million new stroke causes annually. Okay, 1 in 4 people over the age 25 are at risk of stroke. These things. Stroke is the fourth leading cause of the death and fifth leading cause of the disability in India. Stroke prevalence 84 to 262 per 1 lakh population. High burden in rural areas due to lack of awareness and medical facilities. And we'll finally come to a most important thing, that is the treatment cost. How much it costs in India, in which type of treatments. Actually, initial hospitalization itself, it will cost around 1 lakh to 3 lakh in India. Thermobectomy surgery will cost around 1.5 lakh to 5 lakh. TPA injection 30,000 to 60,000. Rehabilitation 10,000 to 30,000 Indian rupees. And these are the average amount. So again, these things depend on so many other parameters like type and private or government hospitals, city, type of treatment, from which city you are taking, and in USA what is the condition. So, and this will start from 20,000 to 40,000 for acute care. Clot removal, it will take $30,000 to $50,000. Rehabilitations for 3 to 6 month rehabilitation, it will $1,000 to $2,000 per month. Total annual cost for long term care, it will be $60,000. So all these things are there. When you see at the money, you will understand what is the importance that we are working on, which type of problem we are working on. You saw the statistical data, you saw the prices for the treatment. You see how hard is this. This is not an easy job, or it is not a very easy to handle like these things. So how our technology, how can deep learning help here? Either to reduce the amount, either to aware the people, or to do something good. Okay, first one is early detection. As you studied above, for early detection always the cost is very less. So what if we can properly detect at early stages? As a human beings will be having so many errors, because we can analyze only some limited data. When the data variation is too much, it is very hard to analyze by a human being. In this case, deep learnings, AI models will come in act. They can analyze n number of data, and one among them is they can do early sign detection with a proper accuracy than human beings, and they can even classify different type of strokes properly. So when they can properly detect the type, then treatment becomes very easy. So when you do the targeted treatment, you will be getting the best results. And for doctors, decision support will also be there, and cost reduction will happen because it is faster, automated data reduces delays and save costs. So now we studied what are the papers are there, why we are doing this project, what is the importance of this project, and all those things. Now I will tell you what we are doing in our project, what is our proposed methodology, and why our proposed methodology is best than the existing proposed methodologies. So few points I may skip here because we can't give 100% everything here. So if you approach us, we'll be giving you one synopsis. You can take synopsis, it will be containing everything. You study that synopsis. Okay, so once you are okay with that, you can just register with us and take the entire project. Okay, you can contact to our team to the given number. Okay, you can just even WhatsApp. Okay, our team will contact back to you. So all these papers we discussed one by one. Now I will be telling you what is our proposed methodology. So here under image pre-processing, no paper is concentrating more. So when you see here, I'll show you a result uh, better than writing there. So these are the different pre-processing techniques we are using. So few pre-processing things I will tell you. So one is, first we try to convert that into grayscale, then we try to apply CLAHE which enhance the images. You see above images which are bit darker. So when you see these, the region of interest are being highlighted. So the brain images are brighter here, but here they are not much brighter. Here white colors is not much brighter, and the edges little bit dark you feel. But when you see the images here, white regions, like the actually region of interest is being highlighted, and background is completely black. So in this case blurriness is reduced, we call that as a CLAHE. And then we apply pre-processing things like Gaussian noise filters, where they will try to remove the small noises within them. Then we do Canny edge detector, and we will try to highlight the region of interest like brains areas. So we are trying to make that very red region of interest. Okay, edge detection is being done, noise is removed, so we are highlighting the images. So we are doing all these things one by one on our dataset, so that our datasets looks much better and region of interest is being highlighted. And then so these things are not being discussed in any existing paper, they are not concentrating much on this. And what is augmentation? As I mentioned initially, there were 950 images in one class. There was some other images 2550, sorry 1552 images. So this is imbalanced data set. Why those papers are not getting the proper accuracy? Why it is getting overfit? So we discussed the third paper was overfitted because he didn't do balancing. First of all, he was using the dataset as it is. So how to balance it? For example, if I have an image here like this, okay, something like this. Now I want to create new image out of this. How can I create? I will rotate this like this little bit. So this angle I will take 5 degree like this. I'll create a new image. I will increase the intensity to 0.01. I'll create a new image. In combination it will happen actually. One parameter will not happen. Intensity, rotation, all these things will happen together to create a new images. So in our case, I am having around 2000 images for each class. I balance them using some stack of augmentation techniques. I'll be giving in detail things if you approach us. So we'll be giving you synopsis what actually we are doing. You can go through the synopsis, then only you can contact back. So now we understood what we are doing, and how we are getting. And when it comes to model building, which model we are using, even we are trying to go with some model like EfficientNet B0, ResNet 50, and then most important thing is even we are trying to go with hybrid models of two different deep learning models. And you can do the combination of like this, and you can work on that. We can try with EfficientNet and MobileNet as a new combination. You can go with DenseNet and EfficientNet, but you need to train for more number of epochs when you increase the complexity of the model by combining 2 to 3 models as an hybrid models. So we are training for 100 epochs where no paper is going for that number. No paper, whatever we referred, is not using 100 epochs. So they are using 20, 30, 50 epochs. So we are training our model for 100 epochs. So then only we are getting so much of good results that you can see here. So this is balancing. I told you we are going to balance. But before balance, what it was, how it was imbalanced, I'll show you just a graph before and after. So this is before. One is having 1550 something and above, near to that, above and below, and one is around 9500 above or below. Okay, so now after balancing, we are getting 2000 images for each class, total 4000 images. Okay, so we call this balancing, and then we do model building and we train it. So we are going to get all accuracy and losses. Okay, then we are going to do it on testing. So you are going to get all these graphs, and then classification report, complete classification report with the test accuracy of 97.25. Then we save the model here. Then we use explainable AI. I forgot to mention in that explanation. What is this explainable AI? I will tell you. So why it is needed? When you present all these special things, it will bring more weightage. For example, so let us take this is a brain. Okay, now when my model deep learning model says it is a no stroke images. Okay, let us take this the brain, and here there is a stroke. Now I will have an explainable AI. Explainable AI power is that when some model will predict this, it's gonna explain us which region was most important area to say that this brain image is actually tumor image, or this brain image is a brain stroke image. Okay, so now you see in the result what it is trying to say. So where there is a blue color here, you see, so above, so this region is making that this brain is a brain stroke image. Understood? This particular region is the most important. It doesn't mean like remaining area is useless. Remaining area is also impactful, but this region is most important to say that this particular image is brain stroke image. Did you understood? Like this is an analysis. This is special analysis. Using explainable AI can get a better result. So once we done with this, what we are doing, how we coded the web application. So what are the web applications? So we have done the coding of all these HTML files, CSS files, JavaScript files. We have even MySQL database. Okay, we are using MySQL database to insert or fetch the data of users. So you see here we are inserting SQL, we are using MySQL, and we are inserting the user ID, password things. So how exactly our web application completely works like? I will show you now complete demo of the project. So this is the main home page where you will be having patient login as well as admin login. When you come to patient login, you will be having option to click on register. You can register using Beanstalk BS1 I'm using. So you can register as a patient. Okay. Now once the patient is being registered with his ID, he can come here and he can log in. So once he logins, he will be taken to this page where you will be having an option to click here. Okay, so now he can upload any image, and then when you click on predict, this image will be sent to the server in the server we will be loading the model that we trained and we saved. That loaded model will be telling us what is this, and what disease is that, and what is the cause for this disease, as well as what are the available treatments are there for this. Okay, so this unless we already done, so we discuss some theory about these diseases. So if you don't discuss those theory, you can't give like this information here. You should know the data, so that's why we discuss about the data. And then we can try a few more images here. Go for LD. You can try anything like combination permutations. You can try to upload few more images and try. Okay, you need to check with multiple images. Okay, so you need to try like that. You should try minimum 50 to 30 to 50 images. Okay, because all these are augmented images, so you need to try 50 to 30 images, then only you will be knowing what actually is happening. I'm just randomly scrolling and I'm uploading. Okay, so random scrolling and uploading the images from our folders. Multiple I'm uploading from a stroke as well as no stroke. So our model is nearly 97 to 99% accurate in the result. You will be having that 3% loss. You can't expect it to 100% perfect, because no model will be 100% perfect. So our model will also not be 100% perfect. Okay, we call that ideal. Okay, no model can be ideal. Okay, ideal. Okay, it means 100% accuracy no model will give. So there will be 3% loss, there will be some wrong prediction coming. Okay, so that should happen because our model is 97%, 3% loss should be there. So this complete code as well as documentation and complete support will be given to you. If you just approach to our team, you can just text to us, you can just WhatsApp to us, or you can call to the number given below. Always will be available for your service, and will be helping you with complete code, documentation and implementation of that code in our system, as well as explanation. And also one most important thing is, once you take the project, in future if you have any small errors or small changes, we will customize it according to your interest. Thank you very much for that. And in the next session we will be coming up with one more good project. Thank you. Don't forget to subscribe, like and share to your friends or colleagues who are in need of like these projects. Thank you.